Okay, I think we can start just with the introduction, with my short introduction. So I leave the floor to you, Max and Adelina, for most of the time. Maybe I'll start sharing my screen. So do you see my screen?
Yes.
Okay. Good afternoon and welcome to this webinar of our Geoscience webinar series. Just a few words about SCAR. For those who don't know SCAR, it's the Scientific Committee for Antarctic Research, which is a thematic organization of the International Science Council. You see it's written in this slide. SCAR now is in place for more than 6 decades. And after its first meeting in 1958, it's acting as the most important, the broader organization for the coordination of Antarctic science and the Southern Ocean. And he's basically initiating and developing scientific research, big science in the international communities. And one of the most important mandate of SCAR is also to advise the Antarctic Treaty Consultative Meetings for the rules about the protection of environment and how to collect the data observation from Antarctica in a quiet and safe environment. How does it work? SCAR is working in scientific groups, and one of them is the Geoscience group. So we are, first of all, I spend a few words about the leading committee. So the SCAR is led by the president, Gary Wilson, who is in the picture here, the one with the red jacket. And he is elected by the delegates and has a mandate of 4 years. And then there is the executive director, which is this, maybe I can use the pointer. I don't know if there is a way to use the pointer. Do you see my pointer moving?
Okay, yes, well, it's possible to see, yes.
All right, so the third to the right is Chandrika Nath. She's the executive director. And then the rest is the executive committee, which is basically preparing all the documents for the delegates then during the SCAR delegates meeting. So as I said, SCAR is divided in science groups. So it's geoscience, life science, and physical science. And we are coordinating the geoscience group. And if you want to know more about our activities, you should subscribe to the mailing list. You can check the QR code here, but also in the portal in the SCAR Geoscience group website, you can find the same information. So from right to left is Jesus Galindo is leading the Geoscience group. Myself as a secretariat, Naresh Pant from India. Jesus is from Spain. I'm from Italy. Naresh is from India. And Giulia Matilde Ferrante, she's got a fellowship to help the three of us Broomers to do some high-tech work. She's also taking care of all our coordination. She's deeply involved in all our business. And the geoscience is basically including action expert groups. So you see them listed on the left. They are ADMAP, the magnetic map, magnetic mapping group, the AntPass with the permafrost, AntVolc, which is the one we'll listen today about AntVolc. The geoconservation group, the GIANT, the gravimetric geophysical data mapping, the international bathymetric chart, and IcePro, which is a an action group dealing with the calibration of paleoproxy. The other groups, Life and the Physical Science, has their own specific action and expert group. Some of them are cross-disciplinary, so Antarchitecture, Antos, groundwater, impact, and rings are basically across all disciplines. We will have some webinars also from these groups. So the agenda is this one. And today is September 10th, so we will have AntVolc presented by Adelina Geyer and Max van Wyk de Vries. And the next will be the bathymetric chart of the Southern Ocean in September 18, and the others are listed here. You can find this list in the website. Okay, so I think we can leave the floor to Adelina and Max. And we will be about 30 minutes of presentation and then question and answer at the end, or I don't know how do you want to manage, feel free to organize yourself. Thank you.
Thank you very much, Laura. I think I give the floor to Max. He's the current chair. So you can start the presentation, Max. I think I'm presenting ourselves or whatever you prefer.
Sure. Yeah. I'm going to kick this off with a little bit of broader context then, and then I'll pass it back to Adelina, who will say a little bit about some of the past activities that we've been involved in AntVolc, and some of the additional context there. And then I'll come back at the end to talk a little bit about our current plans and activities. So first of all, welcome to everyone listening here. Welcome to everyone who listens to this on YouTube afterwards. We're going to be talking a bit about AntVolc, which is the SCAR expert group on Antarctic volcanism. And we'll tell you a little bit about where volcanoes are in Antarctica and so on, for those of you who aren't so familiar with the context. To start off with a little bit of broader context, why looking at glaciated volcanoes is important, I'll tell you a little bit of a more global perspective. This is a map that, amusingly enough, crops Antarctica out, actually. But this is a map from the Global Volcanism Program about where active volcanoes are located around the world. And you already get the impression from this that Antarctica isn't a massive priority from global volcanic perspectives, because we can't see some of the most active volcanoes in the world. They're underneath the bottom of this map. But according to the GVP, there's around 1,000 active volcanoes located around the world. But if we would look at where volcanoes have actually killed people over the past 100 years, we see quite a different trend. We see that the vast majority of volcanic deaths over the past 100 years actually come from a very small number of individual eruptions. This is actually a different trend than what we see for some other types of disasters. If we were to look for floods or landslides, then we'd see much more individual events. But for volcanoes, quite a small number of individual volcanic eruptions accounts for a large majority. In fact, one single volcanic eruption, the 1985 eruption of Nevado del Ruiz, killed more people than all the rest of these volcanoes combined. And what made that 1985 eruption so deadly was that Nevado del Ruiz erupted into its summit ice cap, melted about 15% of that glacier, which then triggered highly mobile volcanic mudflows or lahars, which were able to travel several tens of kilometers away from the volcano, much further than many other volcanic hazards travel. So it's clear from this that if we want to understand and prevent future high fatality volcanic disasters, we need to understand glaciated volcanoes. And as this map that we're looking at in the background shows, that there can be a bit of a gap in this sometimes if we don't consider Antarctica. Antarctica is home to quite a number of glaciated volcanoes, which gives us an opportunity to bring in new information about this. In particular, some of the most active glaciated volcanoes are located in Antarctica. So there are lessons that we can learn that are relevant for understanding volcanic risk elsewhere in the world. And And there are a range of reasons relevant to Antarctica itself as well. And we'll come back to that later on as well. But just a bit of context about why glacier volcanism is something that we might consider. As we just mentioned, it's something that can be incredibly dangerous. Nevada de Ruiz was a good example of this. It triggered these devastating and long-ranging volcanic mud flows. These are something that we know can be an issue elsewhere in the world as well, even potentially in Antarctica. You can also get non-mud flow related hazards associated with, for example, pure ice melt and eucalypts. So those are more like floods. And these have been observed in Iceland recently, for instance. So there are a couple of hazard-related reasons why we might work on glaciated volcanoes. They're also, in some situations, a useful paleoclimate indicator. They can provide us some rare information about the elevation of past glaciers or past ice sheets. This is something that's actually incredibly difficult to get from many other paleoproxies. So glaciated volcanoes or previously glaciated volcanic outcrops can provide us some very valuable information about this. That's been written about quite a lot in different parts of the world, including in Antarctica. These are just a couple of photos. These are actually from British Columbia, but they give us an idea about how we can use these outcrops to understand where ice was located in the past. So that's something that we can use to reconstruct on a larger scale how thick ice was. And because it can be recorded for longer periods of time, we might gain some information, not only about just the most recent glaciation, but also about glaciations further back in time. That's also a particularly valuable thing, because often the evidence of previous glaciations gets removed by more recent ones. And glaciers and volcanic outcrops are one of the rare things that can actually survive that. So they can provide us, again, rare lines of evidence about ice sheets in the more distant geological past. Finally, these volcanic edifices can have interactions with the stability of glaciers. That's something that there's been quite a lot of discussion about. There have been glaciers elsewhere in the world that have disappeared in response to volcanic eruptions. And there are a few ways in which they could impact melting of Antarctica. In general, it's pretty clear that they're not going to have any substantial impact. They're certainly not going to be a key driver, but there are some localized areas in which volcanic ash impacts on the surface of the ice or impacts on local grounding lines could be important. So there is more research that needs to be done on this. And of course, I don't need to tell this audience, but Antarctica is home to some of the largest stores of fresh water. So even things that make quite a small difference to the rate of change in Antarctica can have much larger implications for the rest of the world. So that's just a quick overview about some of the reasons we might work on glaciated volcanoes. I'm going to hand the baton over to Adelina now, who's going to provide a little bit of context about what AntVolc has been working on in recent years. And then I'll come back at the very end of this presentation to tell you a little bit more about our current plans. Okay, I'll let you share now, Adelina.
Thank you, Max. I think you need to stop sharing so I can share mine.
I can do that, yeah.
Thank you so much. Okay. So you are seeing my screen right now, hopefully?
Yeah.
Okay. Okay, so this is the next slide that Max was explaining, and also a bit of context aside of the interest of studying glacial volcanic eruptions everywhere in the world, but also the importance of volcanism or studying volcanism in Antarctica is that, in fact, even if many people don't know that, why is this happening? Okay, it just changing by itself. So even if people don't know that, there are many active volcanic systems in Antarctica. Here is a sketch of them. You can see the ones on gray are the ones that we have evidence of Holocene activity, that is volcanic activity in the last 10,000 years. And then the ones in orange have historic activity. And we consider historic activity 1820s, so the beginning of the 19th century, okay? So you can see there is a bunch of them. So we are not only interested in studying the remnants of old volcanoes or even the paleovolcanism or the activity of volcanic volcanism on the ice sheet or on the climate change, but we have a real problem or potential problem regarding the impact of active volcanic systems today in Antarctica. Okay, so this is all these reasons is what led to a group of researchers 10 years ago, because I realized yesterday that is AntVolc anniversary of the 10 years. So the kickoff meeting was in 2015. And the idea was that there is a need, urgent and pressing need to put more effort, research effort in understanding Antarctic volcanism. Also the paleo one, so everything that happens in the last 200 million years, but also what is happening today and the potential occurrence in the future, okay? So these are the reasons why AntVolc was born. And so you can see the magnitude or the type, better said, of the eruptions that can take place in Antarctica, and just some examples of these active volcanoes. This is Deception Island, which is located between the South Shetland Islands and the Antarctic Peninsula. And this is the blue star here. And you can see these are two images of one of the latest eruptions in Deception Island. And this is then the Antarctic base at that time. This is destroyed because these recent eruptions. So this is one of the very active volcanoes in the area. We have two scientific stations, the Spanish one and the Argentinian one, plus all the different scientific stations in the South Shetland Islands and the Antarctic Peninsula. Another good example, so this is the summary, more or less, of the historic volcanism. We have the last eruptions 1967, 1969, and 1970. And then all these eruptions are what we call in volcanology VA2, VA3. VA reads for Volcanic Explosivity Index, which is, for some reason, sorry, the slides keep changing by themselves. I have no idea why. So the Volcanic Explosivity Index is a way to measure the size of volcanic eruptions. And I put some examples here that you may know. These are the same size of the famous Galeras and Nevado del Ruiz eruption in 93 and 85. Okay, so they are reasonable, moderate size eruptions, okay, in Deception Island. And this is another good example of a very active volcanic system in Antarctica. This is Mount Erebus, which is located here, surrounded by several other active volcanic systems. And Mount Erebus, in fact, we consider it has been active since the beginning of the 20th century, at least that we know, and is characterized by the existence of a almost permanent lava lake on the very top, okay, and quite a lot of activity, explosive activity in its crater, putting into risk the scientific basis of, for example, United States, New Zealand, and even if we consider the potential impact of ashes of Italy, Korea, Germany, all the scientific stations around it, okay? So you can see that even in Antarctica, we have a problem with active volcanism. And we have to add to this volcanic activity not only the hazards related to what we would call normal volcanic activity, which is lava flows, ash dispersal, pyroclastic flows, but those related to the fact that these volcanoes are surrounded by ice. And as Max said, these glacial volcanic eruptions, the interaction with the magma, with the ice, which can lead to a lot of potential hazards. Yeah. So which are the aims from the AntVolc expert group? So first, as I said before, and Max said, promote the study of Antarctic volcanism and inform about the existence of active volcanoes in Antarctica. There were volcanoes in the past, and they are now, and they're going to be in the future. So inform about this, because it's not a general knowledge in the scientific community. then open a discussion forum to establish protocols, methods, and best practices relate in the broad sense, like best practices to monitor, to early warning system, or to tephra studies, for example, best practices how to study tephras in glaciers. I think your system is like somehow predefined to change the slides, because literally my hands are on the table, so I don't know what is happening. So to integrate and share the geological information, facilitate regional correlations in tephrochronology, so share information about the tephra layers we found that can give us information regarding which were the last eruptions, the frequency of these eruptions, compile databases, develop collaboration, exchange data with other SCAR scientific programs, and so on. So we had a lot of objectives 10 years ago. We have accomplished most of them, and the results, the deliverables, the outcomes of these, all the work during the last 10 years is what I'm going to present now. So just that you know, this is more or less the structure of AntVolc. We have over 120 members distributed all over the world. So we have people from over 20 countries. And the steering committee is chaired, so AntVolc is chaired by Max Van de Vries, so you just listen to him, from the University of Cambridge. I'm the deputy chair and past chair. And then John Smiley, he was the chair for many years, University of Leicester. And then we have other members in the steering committee with different kinds of expertise. Okay, everything you can read it on the webpage, and I'm going to give the information later. So we did several workshops in the past. As I said before, the kickoff meeting or Kickstart meeting was in July 2015 in Catania. And then we had the second workshop 2 years later in Barcelona, in the Geosciences Institute, before called Institute for Sciences Jaume Almera. And then COVID came, and then we started to try to do the workshops, but we never managed. But the important thing is that we had several sessions in international conferences at EGU and the SCAR conference, and IUGG, which is International Journal of Geophysics and Geodesy, and then ISAES. So we had appearances in different conferences worldwide. Then the most important outcomes were, as I said before, the databases. So during the development of the life of AntVolc, 2 important databases have been finished or have been established. They are not finished because they are always updated, which is the Antarctic tephra database, where you have the link here. So it's recording information about all the tephra layers, tephra analysis collected in Antarctica to be able to share among the community. And then related also to tephras is the work published 3 years ago already about all the tephra layers related to Deception Island, to be able to identify eruptive recurrence, potential impact, and so on. Regarding publication as expert group, we are very proud of presenting all three of them, which is 2 Geological Societies of London memoirs. So this is the first one, which is Volcanism in Antarctica, 200 million years of subduction, rifting, and continental breakup. These are the sections that the book contains. It was a work of, I think, 3 years of the whole community. Everyone participated. There are a lot of chapters collecting everything we know and everything it's known about Antarctic volcanism, considering the last 200 million years. And I highly recommend that you have a look at it. It is a very nice piece of work for everyone. So then the second memoir was about the Antarctic mantle, geochemistry and geophysics of the Antarctic mantle. These are the 4 sections that contains. I don't know if I don't find my mouse. You can see them here. And it's also a review of everything we know about the Antarctic mantle. This third publication was the white paper. It was, in fact, one of the main objectives of the expert group was to publish this white paper, which tries to make a summary of, again, it's like a summary of the first book I presented you. It's a summary of what we know about Antarctic volcanism, how we study it, which are the problems, which are the needs, and where do we need to go in the future. So potential recommendations of what to do in terms of SCAR activities or national polar committees activities and so on. So it also took us, max, I don't remember how long, but it took us like almost 2 or 3 years to finish this. So it's open access, so you can go and check it. I highly recommend it. Everyone, again, contributed in the community to write it, and it makes a pretty good summary of what we know about Antarctic volcanism until 2023. And then what we have been working, because as we said before, one of the main objectives is to inform about the existence of Antarctic volcanism, is that we made all these reviews about what we know from the scientific point of view, but then we put all this information in a child book, in an illustrated book, to be able to offer the general public information about Antarctic volcanoes, because we consider that there was hardly any information regarding, for example, Deception Island. There is some information regarding Erebus, but they are like the big unknown in volcanism, what is happening in Antarctica regarding volcanic activity. So the book can be downloaded for free in this link that we have included in the presentation. And we have translated it, as I will show you later, in Spanish and Italian. And you can see here on screen what kind of information we are including, like from why do we have volcanoes on Earth, what kind of volcanic hazards do we have, and then will be more general, and then we have specific things like which are the most active volcanoes in Antarctica, largest eruptions, and so on. So we wanted to give a brief overview of Antarctic volcanism to the broad community. So here you have some examples about a general page. These are the hazards, and this is some information regarding Antarctic volcanoes. And this one I like very much, which is the first seeing of an Antarctic volcano by by James Ross. So this is the translation in Spanish. You can also download it for free, and you can see that these books, they are having quite an impact because they are being.
So in 2023, we decided to print these books so we could deliver them to libraries or schools.
Sorry, I'm listening to myself right now.
To print 100 copies in the English version, 25 copies in the Spanish version, and 20.
Okay. Maybe the recording.
I don't know what happened there.
Yeah.
I have no idea what happened. I started to listen to myself. Like,
so, Zoom ghosts, yes.
Yeah, it's okay. It's trying to boycott me. So I have no idea what I was saying right now. So I completely lost track of my own thoughts. But I think I was almost there, right, Max? Sorry. So this is the book, yeah. And so this we also printed hard copies of the books, and we distributed in libraries, educational centers. So the different schools had hard copies of it, and we also can deliver by demand if necessary. And I think that's
in 2023 we decided
again,
to print these books so we could deliver them to libraries or.
What is it, Matilde? Do you know if it's a matter of recording? I mean, it's something going on. Never happened before, so maybe.
Very strange. So I pass the floor to Max.
Sorry, Adelina. Sorry.
Don't worry.
I don't know why.
Okay. I don't know. It's also the first time that happens to me, so I don't know what's going on. I disconnected even the mouse. Maybe it was the mouse, but it wasn't the mouse, so I don't know what's going on. So Max, I think I was finished, so you can continue with the presentation.
It's a mystery. Yeah, thanks, Adelina. Yeah, I mean, if you haven't already had a look at this book online, go and have a look. It's a really nice resource. We have a small earth science museum just across the road from where I am now, and we got a copy of the book in the museum, and I know it's always popular with children who are going to look around the fossils and stuff there. So it does present it in a really accessible way. And I'm going to use that here as the starting point for some of our current work in AntVolc, which is specifically focusing on volcanic risk in Antarctica, and trying to understand what the current status of that is, and what the future steps might be, building on all of the hard work that this work package has done in the past. If we look at what people are doing to look at risk and disaster reduction elsewhere in the world, there's been a lot of work going back 50 years or so. The current main framework for this is something called the Sendai Framework for Disaster Risk Reduction. And that has a few key objectives to reduce disaster mortality in particular, and to increase resilience to disasters. And a lot of this is relevant to effectively any hazard and effectively any environment on Earth, including Antarctica. So a lot of the key lessons in this document and the approaches here are very relevant for Antarctica. But the implementation of the Sendai framework is entirely based around states and state actors. So its application to Antarctica is much less clear. So while the key priorities here of understanding disaster risk, strengthening resilience and governance around it, and all of that are very applicable to volcanic risk in Antarctica, exactly how they could be implemented from this framework is very unclear. Of course, as all of you know, Antarctica doesn't belong to any single country, but it certainly still experiences risk. So just as a starting point from this work, we've been disaggregating risk into its constituent parts of hazard, exposure, and vulnerability, which can be combined together to understand what risk is in any given location. This is a good starting point for Antarctica. In terms of hazard, this is where quite a lot of the work of AntVolc has contributed in the past, understanding where volcanoes are located around Antarctica, how active they are currently, how active they've been in the past, where some subaerial or subglacial volcanoes may well be located. We're now starting to have a better understanding of this, although there's still quite little data in a lot of environments, but at least we have a good idea where volcanoes are located around the continent and how active many of these have been. So this gives us some idea about the hazard. The exposure in the context of Antarctica is about knowing where people, infrastructure, or from certain perspectives, ecosystems as well are located. So from this, we can, for example, go and figure out where all the Antarctic bases are located. This is just showing an example of the OpenStreetMap data sets around Deception Island, which gives us some idea where different things are located. But there's a variety of official databases of Antarctic stations, both existing and past as well, that we can use to get an idea where things are located around volcanoes and what some of the impacts might be from that. Another key part of this is understanding where tour operators travel around Antarctica as well. There's an increasing number of cruise ships that travel down, particularly around the subantarctic islands and to the Antarctic Peninsula, many of which passing close by active volcanoes, including sheltering in the Bay of Deception Island. So understanding exactly where these are located is important for understanding overall exposure as well. And finally, understanding vulnerability is about understanding if an eruption were to occur for different exposure types and different volcanic eruption types, what might the impact of this be? And there's quite a lot of work that goes into understanding the resilience of Antarctic bases, but typically to meteorological impacts, to the extreme cold and so on, not necessarily always to volcanic impacts. So there's some work that this can be building on here. Just giving another larger scale example, this is a map of volcanic ash advisory centers, which are monitoring the impacts of volcanic ash, particularly on the aviation industry. And you can see that in theory, some of these do cover parts of Antarctica, although depending on the sources, the coverage is slightly different. But in theory, many of the Antarctic volcanoes are actually included in some of these ash advisory centers. So there's some monitoring coming from this. And this is just showing one example of a resolution that's relevant to monitoring seismic and volcanic risk in Antarctica as well. In particular, it's recommending that the different parties operating in Antarctica identify and share information with others about what research they're doing on natural disaster risks in Antarctica, and a variety of other things related to that. And there's some information in some of these documents and past AntVolc publications about certain elements of volcanic risk, and we're aiming in this project to bring it together into a single, more coherent piece. So for those of you listening, if any of you are interested in this or being involved in other aspects of AntVolc, please get in touch. We have hearing Adelina's voice again appearing there. I don't know if it's built into the presentation somehow.
Maybe it was built into the presentation somehow, yeah.
Well, but anyway, to conclude, we have a website, so feel free to have a look on there for any information. We're going to be updating some aspects of that as well. We have a mailing list that you can join to add your own email, or otherwise feel free to send me an email and I can add you to that manually. We'll be sending any information out about, for example, future relevant conferences, any group meetings we have on there as well. Thank you very much for listening.
Thank you. Thank you very much, Max and Adelina. Comprehensive view of your activities. Very impressive. Eh? You do many, many things. Also the outreach. So yeah, I don't know if there are any questions, maybe in the chat also, or you can just show up and ask. I see hand. Yeah. Jesus, I don't know if you are saying hello or if you want to say something.
It's an analog hand.
No, it's my hand. It's not a virtual hand. Well, thank you, Adelina, and thank you, Max, for this good presentation of your group. It is very interesting. And one of my questions is, you are, or maybe in the future, you are maybe also interested by the submarine volcanoes, because I have seen that mainly you deal with the volcanoes that outcrop or are on continental crust, but there are other volcanoes, for example, in the Ramfield Strait, along the axis, that may also be active, and also in other areas of the Antarctica. What do you think about to consider also the submarine volcanoes activity?
We consider them, but the problem is that we consider them. We are fully aware, especially since the last unrest in Orca a few years ago. The point is that there is not much information regarding these volcanoes. So of course, it would be ideal to have a project to study them. They can pose a important threat to the Antarctic Peninsula and the South Shetland Island scientific stations, vessel traffic, aviation, everything. But there's very few information. In fact, I see Antonio Polo is connected. He recently read his PhD about the about the Bransfield Strait submarine volcanoes, and the amount of data is really limited. But of course, we include them. It's only that there is no much information about them. So I don't know if, Max, you want to add something about this?
Yeah, I'll second that they're very much, they're within our remit, both subaerial, subaqueous, and subglacial volcanoes are things that we consider is the subaerial ones that we have most of the data about. For the others, they're obviously quite challenging to study, so we're we're basing it on what data there is. I think it's something that we'll want to write a bit about when we're considering the risk. There's a bit of new information that's recently been written about subaqueous volcanoes elsewhere in the world that we might be able to draw on a little bit. But yeah, it's quite data limited.
Thank you very much.
Yeah, it's also true, Jesus, that at least the ones we know, the ones we have studied more, for me as an expert, I'm more preoccupied about the superaerial ones because the size of them, the potential impact of the superaerial ones is much, much, much higher than the submarine ones. But it will be an impact, but I will expect it to be more local. Local being regional, something like that. But for example, an eruption in Erebus or in Ritman will be a huge problem, I think. We have done the models. We see that tephras can escape from Antarctica, then from the Antarctic vortex. I mean, depending of the height of the eruption, they can even reach Australia, New Zealand, so on. So it's we consider them. I will be more preoccupied about the superaerial ones. But as Max said, we have also the subglacial ones. And we don't know where, well, he knows where they are because he did a very nice study in the past about the location of subglacial volcanic edifice in Antarctica, but we don't know how they are.
Yes.
So they can even be as dangerous and as hazardous as the superior ones. We don't know. So we have no idea.
Okay, thank you for the good answer.
There are a few questions in the chat. So I don't know if Andy, would you like to ask or would you like us to read your question? We cannot hear you very well. There is probably a problem of connection.
I think we can read better the question because I don't feel he has a good connection. So, okay, I can read the question. Awesome work with the picture book. How did you find people to partner with for making the children's book? Were the artists, illustrators that knew previously? Yeah, the question is, the answer is yes. So the artist that illustrated the Antarctic Volcanism book, I've worked with him for many years now. And so we had already the contact. He is an expert, a professional in illustrating comics and child books for kids. And we have done with him 4 books already. So the Antarctic Volcanism one is one of them. So we already had the contact, yes. So
okay, and then Arjen, would you like to try to make your question? We can also read it in the chat. If is there a risk that volcanism increases as the ice sheet retreat and thins in some regions?
Max, you want to have this one? It's your
I
area.
could take this one. Yeah. So, I mean, it's something that there's quite a lot of ongoing research about. Evidence for changes in Antarctica is more limited, but we are also lacking data. There's strong evidence that at the end of the last glacial maximum, disintegration of ice sheets caused a pulse of magmatism in Iceland in particular, but also increasing evidence that happened at subduction zones around the world as well. In Patagonia and in North America, there's pretty good evidence of that as well. So it's actually quite likely that if we start removing substantial volumes of ice from Antarctica, it will make the volcanoes more active. Again, quantifying exactly how much more active that would be, like eruptions are already quite sporadic, so they can have a 10% increase in probability and still not erupt. But it is quite likely that more magma would be produced at depth, and it would be slightly easier for that magma to make it to the surface. Yeah.
Yeah. So as Max said, we have evidence from other volcanic areas that this has happened in the past, like Iceland, Cascades in United States. It's true that we don't have evidence, or we don't have data of what is happening in a context of climate change, of accelerated climate change as we are now. But in geological timescales, or fast geological timescales, this has happened in the past. And as Max said, yes, the decrease of ice sheet pressure leads to an increase of volcanic activity at surface. So what is happening in Antarctica right now is the first time we are in a situation like this. So we don't have data about that. But if we have to comparing with what happened in the past, the answer will be yes, it's increasing. How much? Well, that's another question.
Yeah, if anyone else is interested in doing research on these questions, then come and chat to us in AntVolc, yes.
Yeah, thank you very much for the answer, Max, and others. I was in a bus, so I couldn't post a question like that. Now I'm outside in the rain, it's better, but but thank you for that. No, I was thinking just in terms of, the prognosis is for Antarctica to decrease in the future in size. So could volcanism be an additional push to, accelerate that demise of the ice sheets? Is volcanism a part of that in a serious way? Because of course, with all that heat coming up, it does lubricate the ice and it does melt volumes of water. So yeah. Well, thank you. I understand that that the expectation may be there, but there's no data.
So to maybe respond slightly to the second part of that question, I think that our understanding is that it is very unlikely to have a major effect on the rate of melting of the ice itself, from our understanding of how much ice a volcanic eruption can melt elsewhere in the world. The Antarctic ice sheet's volume is actually so large that it will almost certainly be atmospheric and oceanic forcings that will always be key drivers, and volcanism will be at most a tiny modification of that. On the other hand, melting of the ice might well make the volcanoes themselves more active, but it is very unlikely to be a feedback loop, so to speak.
Thank you very much.
So to reply to Anli, yes, the funding for the outreach book came from AntVolc SCAR funding. So we use part of that period funding. I don't remember which year. So we use part of the money to pay for the illustrations 1 year and for the editing and so on. And then another year we paid for the translations and another year for the printing. So we are using SCAR's money for that. Yeah. So in several concepts.
If I remember correctly, this was during COVID when we couldn't do anything else.
Exactly. Yeah. That was during COVID, because we had planned to do all the workshops and meetings and travel to conferences, and then everything stopped for no one knew for how long. And we thought it was a good opportunity to use the money to broaden our audience. And we were also back then we just finished the first book, the first memoir, and we had a lot of materials, and our mind were quite clear of what we wanted to inform about. So we decided to go for the kids audience, because I don't know if you have worked with kids a lot. I know some people that are connected are doing it, but they don't know about the fact that there are volcanoes in Antarctica. Neither the kids, neither many adults. So it's kind of an important audience to reach. There's a big unknown regarding this topic. So.
Yeah, I think the point here that being able to work with an illustrator makes a massive difference, because then they're the experts at communicating information in an accessible way to children as well. If the group of scientists had sat down and drawn these pictures, it wouldn't be as nice a book by a long way. Yeah.
Okay. Any other questions? So if someone wants to be involved, would like to contribute, what's your advice? What's the best way?
My advice, I'll share the links and hopefully we can put them in the description of the recording as well. But have a look on our website, sign up to our mailing list. We've created that as a way to keep track of everyone's email addresses who's interested in this. Otherwise, send me and Adelina an email if you're struggling to access any of that. And any communications about AntVolc we'll be sending through there.
Okay, thank you. All right, if there is no other comment or question, I really thank you both for this nice presentation and for all the work that you have been doing so far. And yeah, I see you next year in Oslo for the SCAR conference. I'm sure that you are planning something, maybe a workshop or some activities. And yeah, I say hello to everybody and I remind you our next webinar, which is on 18 of September, which is the International Bathymetric Chart of Southern Ocean, and there will be Boris Dorschel and Finn Wonk illustrating their activities. And so I hope I see you there. And we are recording, so we can find this same webinar in the SCAR portal of the Geoscience group later, whenever you like. Thank you all, and yeah, see you next time.
Okay, thank you.
Thanks for
Bye.
coming.
See you.